Hi, and welcome to our next video for Math 60. This is section 1.6, solving one-step linear equalities. So in the last video, we solved linear equations or linear equalities, which, as a reminder, a general linear equality is a times x plus b equals c, where a is not 0, and these are all numbers. All right, we know what numbers they are, but in the general equation, we'll leave them as letters to say that they could be any numbers. A linear inequality is basically the same, except now we can do a times x plus b is less than c. If you recall, we talked about the inequality signs. Or a times x plus b is less than or equal to c. Or a times x plus b is greater than c. Or a times x plus b is greater than or equal to c. We're going to do all the same math here with a little bit extra. So if you think back to the first video where I talked about how math is building on what you've already learned, all of the skills we use for this are going to build on what you learned solving linear equalities with a little bit extra. So my general approach to solving any inequalities. Here they're linear inequalities, but any inequality. First one is solve, or the first step is solve the equality first. A lot of times when I do math or when a lot of mathematicians do math, part of it is you say, you gave me a hard question. I don't want to do that hard question. I'm going to do the easy one. Solving a linear equality, I don't know how to do that, so I'm not going to. I'm going to turn it into an equality and just solve that instead. What this does is this gives you the endpoints. And I'm going to walk through an example where I demonstrate what this is. This gives you the endpoints of the interval of solutions. If you remember from an earlier video, we talked about how inequalities usually have not just a single solution, they have a whole interval of solutions, where intervals have endpoints. And the endpoints are where the equality exists. And then step 2 is I test numbers on either side of the endpoints. Sometimes there's only one endpoint, sometimes there's lots of endpoints. But if you test numbers on either side, this will give you the shaded part of the interval. That is not just the endpoints, but which side of those endpoints belong in your solutions. Let me give you an example. By the way, this is not necessarily the most common way to teach solving inequalities. The most common way is just to do your steps, leaving everything as an inequality. But I find that to be more confusing for myself. And there are times when using those steps really doesn't work. So I consider that to be a limited solution. And this is a process that will always work. So here's an example. Solve the inequality x minus 7 is less than -2. And my first step is to say, no, I'm not going to solve that inequality. I'm going to solve the equality x minus 7 equals -2. Because that's going to give me the endpoint of any solutions, and it's easier to solve an equality because I already have the tools for that. I've been asked to explore a little bit farther on my map, and I say, first, I'm going to do what I already know how to do. So solving the equality, as we've learned, we can add 7, which will cancel out the x minus 7 part and give me x equals 5. So this is the endpoint of the interval. Thinking back to the video where we talked about showing intervals on a number line. There's my endpoint of my interval. Now remember, an interval starts somewhere and then it shades areas. So now I need to find out, is my solution set shaded to the left of the 5 or is it shaded to the right of the 5? And to do that, I'm going to test a point. Let's test x equals 0, because that's a really easy number to test. And how about x equals 6? Because 0 is the left of my endpoint and 6 is to the right of my endpoint. So if this one works, then all of that works. And if this one works, then that part works there. So thinking back to our notation, I'm just going to squeeze it in here. If x is 0, I have -7. And it is true that -7 is less than -2. So that means this point x equals 0 is a solution. But that also means that that point x equals 1 is a solution because it's down here in this interval. And in fact, everything in this interval is a solution. And I can test x equals 6. So if I take x minus 7 and I put 6 in, well, that's -1. Is it less than -2? No, it is not. So that means nothing on the right side is in my solution. And I forgot my last little part. Decide whether to keep the endpoints. Do I include 5? Well, for that, I just look at the sign. This is a strict inequality, which means I do not include 5. So I'm going to put an open parentheses right there. And unfortunately, I'm going to have to move to the next page. But before I do that, let me add here, decide on the endpoints based on the type of inequality. Okay. All right, I did that one. I'm using a graphical approach. I'll do another example, and this time I will also write it in as interval notation. So let's solve -3x is greater than 4. And this actually demonstrates one of the challenges with just solving this thing like an equality. If you just divided both sides by -3, you have to be careful about which way that sign is, the inequality sign is pointing. But if first we solve the equality, and I'm going to make this a little easier on myself, I'm going to make that a 24. Gives me all whole numbers to work with, or at least integers. Oops. 24. Okay. So first I solve the equality. I just replace that inequality sign with an equality. I'll make it a little different too. I'll make it a greater than or equal to 24. The -3x greater than or equal to 24, I just change it to a plain equality. I divide both sides by -3, and I get x equals -8. So that's the endpoint. So now I draw my number line, and I really do recommend that you do this pretty much every time until you get super comfortable with thinking about inequalities without the visual representation. This is a visual representation of your number line. Skipping a little bit, let's make that -8 right there. Okay, so that's my endpoint, and now I'm going to test the number to the left and the number to the right. So let's test x equals -10. And we can test x equals -7 because it's right next door. I usually recommend picking the easiest point to test. And for me, 0 is usually pretty easy. And -10 is a little bit easier than -9 because I can do arithmetic in my head with -10 a little bit easier. So we're going to have -3 times -10. That's +30. Okay. And yes, that is in fact greater than 24. That means everything to the left of -8 is in my solution set. And if I test -7, I get 21. And that is 21 is not greater than 24. So that means nothing to the right of -8 would work. And then lastly, I decide, okay, this less than or equal means to include the endpoint with a square bracket. So I'm going to put a square bracket right there. So that's my visual. And now let me convert this visual representation of my solution set back into a symbolic one using interval notation. X is in the interval. If you remember how we do this, first you find the endpoints. Well, this one goes down all the way to -infinity and comes up all the way to 80. Sorry, -8. And then we decide, do I include -infinity? Never. And in this case, do I include -8? Yes, I do. And now I'm done. And that's how you solve one-step linear inequalities. It's pretty easy to build a word question around an inequality. If you think back to the previous video where we were talking about the tips on a restaurant bill, I could say, what's the smallest tip I could give that is at least 15% on my bill? As soon as I'm saying at least, it's a greater than or equal to. All right. Looking at the end of section 1.6, there's actually a two-part linear inequality here. So I'm going to do an example of that. Maybe I'll first do a two-part equal. Well, I was going to say maybe I'll do a two-part equality, but remember when you solve an inequality, the first thing you do is you solve the equalities. So it's going to give us a chance to practice both of those. So let's solve -2x plus 8 should be strictly less than, let's say, 14. So now we have two parts, but that's okay because we just take it step by step. First, I'm going to write this as an equality because that brings me back to something that I've done more often, to a place on the map that I know better. And solving this, I want to get all the x's on one side and all the numbers on the other. So let's start by subtracting 8 from both sides. And we get 2x equals 6. And then divide both sides by 2, and we get x equals 3. So that's my endpoint. And everything else is like what we've just done. Let's build our number line. 0, 1, 2, 3. That's the endpoint. And so I'm going to test numbers bigger than 3 and numbers smaller than 3. Well, the easiest number to test that's smaller than 3 is 0. And bigger than 3, I mean, I think 4 is easy enough to test. So if I test x equals 0 in my inequality, I have minus 2 times 0 plus 8. Well, that's just 8. And is that less than 14? Yes, it is. So that means everything in the 0 part of the interval is part of my solution set. I hope that you're recognizing for these simple inequalities, it's either going to be everything less than your endpoint or everything greater. It couldn't ever be both of sides of it, but let's test just to be sure. Negative 2 times 4 plus 8. I'm noticing something that I think maybe I did wrong. Aha, this is good. I'm going to work through my error. And that's going to help me catch what I did wrong. So I do negative 2 times 4 plus 8. Well, that's negative 8 plus 8, which is 0, which is also less than 14. But remember, before I paused and confused myself, I had just said we're never going to find the solution set being less than number and also being more than the number. But it seems like I just did. And now I have to ask myself, what went wrong? Did I pick the wrong endpoint? Did I do some bad arithmetic? Or has the world of algebra changed so fundamentally that now a solution set that used to be impossible is now possible? Well, it's probably not the third one. So I'm just going to go back through and I'm going to work through it again. Negative 2x plus 8 equal to 14. So I subtract 8 from both sides. That part looks good. And then I have 2x equals 6, but it's not supposed to be 2. It's supposed to be negative 2. I missed that. That's a negative 2 and a negative 2. So it should not be 6 divided by 2. It should be 6 divided by negative 2, which gives me a negative 3. So this whole part here is wrong, and that's a part of life. Everybody makes mistakes, especially doing math. And so I start that part over. I have a new endpoint, which I can check to make sure it's correct. Negative 2 times negative 3 is positive 6 plus 8 is 14. So I get my number line, and actually my endpoint was supposed to be here at negative 3. So now I'll test a point to the left of negative 3. How about negative 4? And a point to the right of 3. How about 0? So I have negative 2 times negative 4 plus 8. That's 8 plus 8, which is 16, which is not less than 14. So this side here has to be excluded. It's not part of the solution set. And I already checked that 0 works. So my solution set is actually there. And step 3 is decide on the endpoint. Well, the less than means exclude. So I'm going to use an open parentheses. And now I can convert this to interval notation. X is in the interval. My endpoints are -3 and positive infinity. I said I couldn't get to -3, and I can never get to positive infinity, and then I'm done. So that's how you do a two-step linear inequality, and also how you check yourself when you run into something that doesn't make sense. And that ends our video for today. Next video, we'll be working on some algebraic properties of numbers. Thanks for watching.